those who weren't here for a day or two, this is what I'm expecting in terms of that worksheet, doing the problems this way. I did correct for 2, the early one, where you didn't have this sheet. I just demonstrated it, and now I want it done this way, dealing with concavity and also slope. Yes?
We need a number 55 to find like the points.
The concavity ones?
55.
Okay. Now, in a minute. Okay, here we go. This is what I want to accomplish today. We have looked at the second derivative test. Okay? And page 241 is the way it's in your book. And it says we have to have f at x, or f prime at c equal to 0. Okay? That means what? What is this thing? Critical point. Okay? And we have to have f double prime existing at that point. Okay? Then, if f double prime is bigger than 0, then this is a local max. Now, I don't know if you're catching on to this, but this is really, really fast. Okay? And so, if it's less than 0, it's a local maximum. Okay? Or if this is, less than 0. Okay? Now, let me show you how this thing works. We'll start with a very easy one. And, but this is the big kicker on the last one. If it doesn't work, then you have to go back to the first derivative test. Okay, here's my the function that I'm going to use. I'll put this way up here. We're going to go y equals x squared minus 4x plus 4. There's my function. We'll quickly draw this thing. And I think it gets graphed this way. Okay? And, okay, so what I'm going to do is I'm going to take the first derivative of this. We'll call this equal to f at x, like this. So f prime at x equals 2x minus 4, which is equal to 2 times x minus 2. So my critical number is what?
2.
2. Okay? Now, I would like everybody's attention. Okay?
Where are you?
Okay, now, I'm going to take the second derivative of this thing. Like this. And that's equal to? 2. Okay, now I've really got too many 2's floating around here. But my...
Wait.
What?
Write 2 in the second derivative.
Here?
Yeah.
Because I'm taking a derivative of this.
Okay.
2x minus 4. Okay, now this thing tells me what? What is... This is a second derivative test. This here, I'm putting...
It's a minimum.
So this is going to be a minimum. It's a positive number, so it's a local minimum. Okay? Now, another thing is, what is the rate of change in this whole thing? It's concaved up, and it's so boringly always 2. It's changing constantly at the rate of 2. Okay? That's this one. Now that makes this problem a little bit too easy, but I wanted to show you one. And now I'll show you another one that's a little bit more work, if I can find my spray bottle. I don't think we need that anymore. And I have a few problems for you to do, and I didn't choose terribly difficult ones to find the derivative of. Here's a third degree equation. Let's go f at x equals 3x to the 4th minus 4x to the 3rd minus 6x squared plus 12x plus 1. Okay, now it's a 4th degree equation. 4th degree equation, and what's in behavior? Up and up. Up and up. Okay, so it's going to turn into something that looks like this. Somehow or other. It's going to be up over here, up over here. It could take a loop-de-loop in the middle. We don't know what it does. I'm not graphing it. Okay? So, I'm going to take the first derivative of this thing, and that's going to equal Okay, now, when I taught you how to factor these things, there's something about these that you should remember how to do it quickly, because thirds are not always so easy to do. I'll take a 12 out first, and then I have an x cubed minus. Now notice, what is the sum of all my,
1.
no, it's the sum of this is a 1, minus 1, minus 1, plus 1, that's 0. So 1 is going to be a solution to this thing. Okay? Otherwise, you gotta just go find it. Now, you've got a lot of tools out there to find them these days. You could graph it and find the zeros. You could also use synthetic division here. And with synthetic division, you have a 1, a minus 1, a minus 1, and a 1. And if you put a 1 in here, what do you get? 1, 1, 0, 0, minus 1, 0. With me?
No.
Got that?
No.
This is, well, go brush up on your synthetic division, okay? Now, with this in mind, what is this factor? This produces what factor?
0.
You with me?
No.
Looks like you're gonna have to go back to the old elementary school division longhand if you don't remember synthetics. Otherwise, talk about it again next time because we don't have time today. Okay, now what I'm saying is this. This is equal to this, and it's gonna be x minus 1 times this one, which is another x minus 1 times x plus 1. Are you with me?
No.
No or yes?
No.
What are the factors of this?
X plus 1, x minus 1.
Okay, so you got those. And what's this? That's x minus 1. So I highly recommend you spend a little time with this or figure out some other ways to do this. Okay.
So that's synthetic division, you're dividing by x minus 1.
Yes,
How did you know to do that?
I taught you that. Okay, so this is the long division one. I'm not going to put the 12 in there. I could, but that makes it too hard. Okay?
Why are you dividing by x minus 1?
Okay, now, hey, just a second. The question is, how did I know? Because I made a lucky guess. Or I knew something. And the ones you want to check first is, does 1 work or a minus 1? You got to just figure some of these out. And sometimes you're going to have a 4 here, and so you got to figure out how to do that. Another thing I taught you is that you have a ratio. If you're going to have any rational numbers, it's going to be the factors of this divided by the factors of this. Now this one's boring, and that's just 1 and a 1. I taught you the rational root thing that way, okay? That's over here and over here. So now you divide this. But I don't want to go there very much. I don't want to reteach this at this point. But you're going to run into this in these problems, so you have to learn how to do that, okay? Now, what are my zeros here? Or what are my critical numbers?
1, negative 1.
Okay, critical numbers are x equals 1 and a minus 1. Okay, now I'm going to go back up to here and find the second derivative. Okay, what's the second derivative of this thing?
36x squared minus 24x plus minus 12.
Okay, now, what I'm going to do now next is what? Put these critical numbers in here. Okay, so f double prime of 1 is
0.
therefore, what is true about this? We have no clue. That says that we have to go back to, if it's equal to 0, you have to go back to the first what we did with the first derivative test. Okay? Now, try the next one. We'll try f double prime, and see, this is really kind of nice, minus 1, and that turns out to be, no, this is going to be 36 plus 24 plus
48.
Okay, 48, which is,
The max.
Concave up.
Pardon?
Sorry,
That's
that's
the
like
maximum.
It's a minimum. Or it's a minimum?
It's a minimum.
this is going to be a minimum, because it's going to look like this. Okay, it's concaved up. This means concaved up. Okay? And therefore, this is that one. Now, Are you ready to do this other one? Because we don't know. Is it something? Now, the reason we get into a little trouble here, this one over here is a double root. You see it? It's a double root over here. And that could spell trouble each time you have it. Okay? But just know that it's there. Okay, now, so I've got to go back to this one here. So what am I going to do with that? First derivative test. What do we do with the first derivative test?
Intervals.
Okay, and now we got all that done already. We have, and what is the key point of this interval? Where does it stop?
One.
1. Because that's where we got the 0. So that's where we're going to try a number a little larger than 1 and a little smaller than 1. Are you with me? Now don't go too far because then you could be into trouble. So, what's a number just a little bit more than 1?
2.
No, it's way too big.
1.1.
1.1. Okay, 2 you could have jumped way into something else in terms of relative stuff or local stuff. Okay, and what's one smaller?
0.99.
You may, okay, now, okay, so we've got these two numbers. That's nice. You told me we're doing this here, first derivative test, and we're going to use 1.1 and just 0.9, that's okay. 0.99 is all right, I don't care. Okay, now what are you going to do with that? So you got those two, so what?
Put it in the derivative.
Put it in the first derivative. Okay, so at this point, what I would do is dump, you can do either one, this one or this one, in your calculator and just put these numbers in. Because that gets kind of messy. Okay, and you know how to use your calculator with us in your table? Any questions about that? And I believe I did that. Did I use those numbers? Yes, I did. I put, that's there. When I put up here, f prime at 1.1, I got a 0.25 out. And when I put this one in this morning, I put in 0.9. But by the way, DeVries told me to put in 2 a while ago. I did that dumb thing this morning. And then I got a wrong number. And it didn't work. Okay? And so now this is equal to 0.228. So, what? Now what?
It starts going down.
Oh? Is it?
Is it going up?
Oh, what's going up?
The slope.
Zach says the slope is going up both places. So what?
It's increasing.
It's increasing on this, pardon?
It's concave up.
It's a local map.
Okay, hey, this is very important. We've got a critical point right here. We're going up here and we're going up here. So what is this?
Nothing.
Nothing. Pardon?
I thought it was an inflection point.
Inflection points happen when you go from concave up to concave, and that's a second derivative equaling 0. Okay? Just a second. Just a second. Just a second. I think that is an inflection point. That is an inflection point.
You can still be going, yeah, you're still going up even if you're going.
Yeah, so it'd be going this way and you're probably, and it's an inflection point. Okay? Which was a free kind of gift we got there. Okay, now, the next thing I'd like to do is point out a couple things in terms of the assignment. This one right here, Chanel has her book open to page 242. And that's a summary there. And this is not a very difficult problem, I don't think, but see if you can get all this apart. And then these two, or no, how many of these? This one and this one, I think. Gives you some data, and you have to do a graph. Okay? And that really helps you understand what's happening at all these places. Okay? So work at that. And let me see what, I don't remember, 76. 76, oh, those are second derivative tests. Okay? Now, a quick summary of some stuff. Know how to do this. Okay? And now know the second derivative tests. And then on Monday, we will be into applying this to various problems, application problems. Okay? Now, I accomplished what I wanted to today. Somebody said a question about 56,
55.
55.
To find like.
Okay, here we go. Take a look at this. It's going to be a continuation of what I talked about a little bit earlier, learning how to factor. 3t to the 5th minus 30t to the 4th plus 80t cubed.
Which number is
Okay, now you did do the problem in terms of factoring it, right? First derivative is what?
15 to the 4th. 120 to the 3rd. 240 plus 240.
Okay, now,
Yeah.
what common factor all the way along?
Square.
15t squared. Okay, and so then you get t squared minus
8t.
16.
T minus 4 squared.
Okay? See, now this one here isn't all that difficult. In that he left the ones off the end here so you didn't have to
So is there-
fifth degree.
Is there just two intervals then on that one? It'd be negative infinity to 4 and 4 to infinity.
I think
Well,
so.
no, there's a 0 though, isn't there?
Yeah, there's 0 to 4. So there are 3 intervals.
Okay.
And does it turn out to be there's nothing too significant happening, or are they significant? I don't recall. Okay. How about problem 70? Will you guys look at that a minute? So you don't want to?